Hey students, here's a video that's going to go over the concept of 2C, which is rewriting polynomials in their factored form. We talked a little bit about the two different forms that you could see polynomials in. One of them is standard form, where you have ax squared plus bx plus c, where a, b, and c are any numbers that you could think of. The x's will be there. Then there's factored form, where you have x plus some number m, and then you multiply it times x plus some number m. These are the two different forms of polynomials, and they represent the same type of things, but they're just written in different ways. You could think of it like a name, right? My first name is Dalton, and my last name is Elkins, and usually when I'm in a more social setting, people will call me Dalton. However, you guys know me as Mr. Elkins, and when you see me at school, you probably call me Mr. Elkins. I'm still the same person, depending on how you call me, but two different contexts are relevant there. So we need to go from one form to another, just so we can know how to rewrite these things. When we go from factored form here on the right to standard form here on the left, we use the box method, which in case if you forgot what the box method is, you can go back and look at any of my 2B videos to get refreshed on that. However, to go from standard form to factored form, we use something called MAF, which stands for multiply, add, and factors. So, using the A, B, and C numbers that are up here, our goal is to find three things. We need to find two numbers that multiply to C. Multiply to this number right here, which I'll highlight in green. Then we need to find two numbers that add to B, which is the coefficient in front of the x. Not the x squared, but the x. And these two numbers are called our factors. We're looking for two exact numbers that when you multiply them, they equal this C, and when you add them, they equal this B. It's kind of like a riddle. So the best way to do this is just look at an example. This is one of those types of units where you just have to get your hands dirty and try it out. So here we have an example, x squared plus 5x plus 6. So we need to know what the C value is and what the B value is. These are placeholders that represent numbers. So if I look back at this here, C is the number that gets added on at the end. There's no x variable attached to it. So in this example, that'll be 6. So what I want to do is I want to find numbers that multiply to 6. Next, I want to find my B value. The B value is the number that is right in front of the x. It's a coefficient. It's being multiplied to x, not x squared. Here's going to be 5. So I want to find numbers that add to 5. Okay, so to go about this, I'm actually going to be sharing with you this factors chart, which tells you all the pairs of numbers that multiply and equal any number that you're looking for. So here we're looking for the number 6. So I'm going to find 6, which is right here. The two numbers that multiply and equal 6 are 1 times 6, so it's one pair, and then another pair is 2 times 3. So if I were to multiply those, 1 times 6, that equals 6, and then 2 times 3, that also equals 6. We need to see which ones then add to 5. So 1 plus 6, see if that equals 5. That equals 7. Okay, so this isn't our set of factors. However, if I try 2 plus 3, that does equal 5. So 2 times 3 does equal 6. And 2 plus 3 does equal 5. So our factors are 2 and 3. Now these are both positive 2 and positive 3. So if it's a positive number, we write it added to x. Added to x if it's a positive number. It says this right here. Let me highlight this for you. So my factored form is going to be x plus 2. Notice I'm using the parentheses here. And then x plus 3. That would be the factored form of x squared plus 5x plus 6. Thank you very much. I'll see you soon.